G'day folks, in today's video we're running through how I created the latest moving bed bioreactor for our aquaponics system in Ipswich. I'll be running through the build component wise, step by step, and at the end of the video I'll have some helpful tidbits looking at how much bio media you need per system. So that's enough rabbiting on, let's get started by chopping up the bio drum. I already have a video on how I've cut these guys up to make a radial flow settler, so I won't go through that here. You can check out that link down in the description. But just a bit of a rough idea on what I'm doing is I'm trying to match up this groove here with the side profile of the drum itself. So after we chop it off, we can flip it over and the exposed bit of drum here will fit nicely within that groove, just so it's a nice secure seal. Basically just chop and flip the top of this. I'm just going to be cutting it up inside this tray so I don't have to try and get all the bits of blue plastic from all around the yard. So I'll stop nattering on, we'll set this camera up and we'll get into it. So I started off by marking out a rough line, then drilling a pilot hole for the jigsaw, and then just used the jigsaw to remove the top. The top here, I did go off track in a couple of places, but nothing too drastic. And you can actually see the abnormal molding style of these barrels here. They tend to be fatter in some places than others, but the lid fits on nicely. I could probably trim it down and get it to fit a little bit more snugly, but I think that will do. Now the entrance pipe to the moving bed bioreactor had to be the same height or slightly lower as the exit from the radial flow settler, so I decided to make it the same height, which was roughly around about 760 millimeters from the base of the drum. And the exit pipe needs to be at the same height or lower than the entrance pipe into the bio, otherwise you're going to have problems with the water backing up and possibly overflowing. Just a bit of a heads up, these things, because they're molded, you have a seam on either side. So the seam on this one is just here. So I placed the mark, it's about 30 mil off to one side, but it's easy enough just to come over here and say I'm going to drill there on the seam. And that means just on the other side here, we can do exactly the same thing. Coming up, roughly 76 mil. There it is, 76 mil from the seam. And that's it there, that's where we drill. And we know that those two holes will be directly opposite each other. So we have an inlet and an outlet. Might actually use my noggin and drill this one from the inside. And that way, all the swarf, most of the swarf will stay on the inside. There we go. And on this one here, I'm going to do exactly the same thing. So I'm just going to start the pilot hole on this side. Then we'll go to the inside. And just to clean these guys up again, I'm just going to use the deburring tool. And the same on the inside. This one's very messy. There we go. There's a few bits on the inside there that I'll just take off with a craft knife later. They shouldn't pose an issue. I'm only going to put a drain fitting in here, just so when it comes time to pull this down and move it, you can take the bulk of the water out and it won't be really heavy. You don't really need to worry about solids in the bottom of these, I found. There's so much air down there that even if some do accumulate, you don't end up with any anaerobic issues. So I'm using a 1" or 25mm pipe here, so I need the same uni-seal. Now the holes for these require a 44mm or 1 3/4" hole, and easy enough just to zap it straight through. And we put the lock on the drill again. There we go, fairly easy. Just clean up the outside and the inside using a deburrer. Away we go. So with that done, it's time to build the drains for the bio. So this little drain assembly is made using an 1.5" or 40mm end cap with a series of holes drilled in it. Now we have a reducer from 40mm down to 25mm or 1.5" down to 1 inch that is then glued inside that. And then there is a section of pipe that is glued between the reducer and a 90-degree elbow. That's it for the internal section of the drain. For the external, we have a 25mm or 1 inch valve that has a section of pipe glued inside it. That pipe will run through a uni-seal fitted to the wall of the bio, and the internal components of the drain will be connected to that later on. Just a bit of a quick heads up, I've just added a module to the guide that looks at a few ideas on making these guys. Not only that, how to use the glue to glue these bits and pieces together, and also a option where you can just fit them together, and so you can reuse the parts later, but that makes them water and airtight. So check that out if you have the guide. Now we're going to get on to plumbing the radial flow settler to the Moving Bed Bio Reactor. Just a bit of a tip about preparing pipe for the uniseals. There's a link to my website that goes through it in more depth. But basically what you want to do with these larger ones is create a bit of a large bevel around the edge. Just helps to get it started off. And on these smaller ones, I don't know if you can make it off. It doesn't have to be as pronounced, I find, just as long as you take off that sharp rim. Anything from a 1/2 inch, which is 15 mil, up to about 32 mil, which is 1.25 inches, can be pretty much all started off with just a small little nick off that sharp edge there. Don't forget to check out my page for a more in-depth explanation, and also pick up a couple of uniseals if you're in the market for some while you're there. So I've got a section of timber in there, and I've lubed up the uniseal with a little bit of dishwashing liquid, and got the end cap on again. Hopefully it'll start off fairly easy. Through we go. Now this one here needs to have a fitting on the inside, so it needs at least 30 mil coming through. And I think that is pretty much all it. So because we got that section of pipe in there, I'm just going to hang it over the edge there. And I've also grabbed just a little bit more dishwashing detergent, pop that there, put my brace timber inside. This one here is a bit longer because it needs to reach over into the sump tank, and should be fairly easy to start off because it's got a larger bevel on it. And again, we just want about 30 mil or 1.25 inches on the inside, just enough to take a fitting. And last but not least, the drain valve for the base of the Moving Bed Bio, and that just goes in easy as. Now we'll set these up in situ. So now we'll disconnect these guys before we put any drain fittings in. So these rubber cuffs, again, pretty easy to put on. There we go, that's one side. And now the next side. There we go. And it's as easy as just doing up the clamps, and we're right to go. The next jobby on the cards was to plumb up the internal pipe work. I used Teflon tape around the pipe, pushed it on, drilled a hole through the fitting and the pipe, and put a 316 stainless steel screw in there to create an air and watertight seal. And just to show you, the lids now fit nice and firmly after I trimmed off those fatter bits on the inside. So the last job at this point was just to pop in some drain work that takes the water from the bio into the sump tank, and then add water to the entire system and give it a bit of a wet run just to make sure that all the pipes were leak proof before we proceeded further. So the internal plumbing and the biomedia for this bioreactor weren't added in straight away. They came down the day that we moved the fish from the existing system into this brand new system. Now the drain fittings themselves were made from 50mm or 2-inch PVC pipe that had a number of slits and holes cut into them with an end cap on each, and the end cap also had some holes in there. Now one warning I would give you is to make sure you have more than enough openings on the pipe itself, either slits or holes, to allow enough water to come through the pipework into the next section of your system, so you don't end up with any water backing up. Every flow rate will be different, so it's a bit hard to tell you exactly how many you're going to need. So to begin with, I need to take out the fittings from the Moving Bed Bio Reactor and the little air stones that are in there. So people have asked me how much biomedia is in here, and to tell you the truth, I forget. I think it's 30 litres. These buckets, I think, are around about 15 litres. So we're just going to put this media straight into the biofilter now. Whoops, and make a bit of a splash. And none went over the back, that's a good thing. I've actually stuffed up because I've just realised I haven't put the correct inflow yet in here, but we have an outflow. This was the inflow as you saw it before, just pushed on here as an outflow. Pop the lid back on, get another load. So just to show you folks, I can now take this section here out that the water level is low enough, and this will be our inflow into the other filter. So I'll put it in with this bucket here. So now to get the rest of this out and try not to spill it everywhere. So now we're going to put the inlet in. I'm just going to take that T-fitting off, And we're going to put this inlet on with a 90 degree because I put these holes right near the top to basically allow as much water as possible in these drums, both of them. And this outlet here being at the top will prevent any siphon from occurring. And that media shouldn't go back to the radial flow settler, but I've seen stranger things happen. So I'll just bring it down close. And I think that's good enough. So there we go. We have the water now entering down through the 90 at the bottom, and then it has to come up through this pack, which I'm not too happy with the way she's going. There's basically, I don't think, enough in there, but yeah, it'll do for now for what I want. I'll only know once I add the next lot in. Yeah, as you can see, we are having issues. Another thing I can do is have this going straight out. I'll just go look for a fitting. So there we go, folks. I'm pretty happy with that. I'm going to fine tune it a little bit and probably put another one of them in there. Yeah, just so we get a wider spread of bubbles. I wasn't happy with that because the media isn't at a nice sort of slow boil. So what I did was spliced in a T-fitting, then run 2 bits of hose down either side of the collector there and popped an air stone on the ends. And that is pretty much, well, spreading the air further around the drum. So we only have a little bit of media stuck around the rim there. And that, yeah, there's nothing wrong with that. That you might be able to see the media below that is moving slightly. So I'm not really concerned about just a little bit hanging around the outside. We have a nice boiling on the inside. The bacteria has loads of air to help it do its process, and we have a nice exit flow out into the sump tank. And the lid fits on nice and snug. I ended up drilling a hole just under the lid on the reactor itself and fed the air line through there just to tidy things up a bit. And just quickly, the air for this biofilter comes from a roughly 4,800 litre per hour air compressor kept in the electrical box, which is also where we keep the backup system for the main air into the fish tank. So that's the bill sorted. Now we'll get on to some helpful pointers and sizing your biofilter. Rhonda was wondering how much of this media we actually need to keep the fish waste processed. Well, in my case here, I'm in the subtropics, and it pretty much all goes for the same for the temperate to the tropical zones. 1 litre or about a quart of this stuff here. This is the PEO3 biomedia. It's a little 5-spoke wheel. I think it's K2 in another brand. We need about a litre or a quart of that to process the waste from the amount of feed given to a fish at harvest size, which is roughly around about 500 grams or 1 pound in weight. Now there are some more in-depth equations, mass balancing equations that commercial folks will use, and even folks with larger backyard aquaponics systems than this, especially those folks who run the deep water culture or nutrient film technique without any media beds. But they involve basically knowing the exact surface area of these little fellas here, or how many square meters or square feet of surface area they provide per cubic meter or cubic foot. And then they have to work out the amount of feed, the protein ratio of all that. And yeah, it's pretty much, well, a little bit of an in-depth calculation to make, because also consider all the inside walls of your drums, your filters, your fish tanks, your pipes. They also create biological surface area for these bacteria to inhabit, as do the roots in the deep water culture and nutrient film technique. Now, along with how much media per fish, you also need to work out how much media you can have in one of these vessels so it will freely move. So when this media is brand new, it tends to float on top of the water, but as the bacteria colonize these little wagon wheels, they tend to become almost neutrally buoyant, and that allows them to basically tumble through the whole water column within the filters themselves. To allow this movement to happen, the churning, you probably don't want to pack any more in than about 50% to 2/3 of the media, keeping in mind the more volume of media in there, the more air and movement you're going to require. Now, in our old system, we used a Venturi, and we had that running directly from an oversized pump, and that helped churn the media. Not only that, but provided air for it as well, so the bacteria could oxidize the waste. So I hope you enjoyed that look at the most recent moving bed bioreactor build we had for our aquaponics system down in Ipswich. It's nice to have it all laid out step by step, I think, rather than bits and pieces over a few videos. Now, if you do want to see that complete system build, there is a video available. It'll pop up at the end of this video here, and it's also down in the description as well. A quick little shout out to all those folks who have bought our Backyard Aquaponics for Beginners guide. It's an online guide, $19.95 US. You would have seen an ad pop up already. Check that out if you are interested in starting your own aquaponics system and you're totally new to the idea or the concept of growing your own fish in the backyard. So I will pretty much all leave it there, though. I do hope you're all well and happy and your own aquaponic systems, gardens and farms are booming, and I will catch you next video. Cheers folks, and have a top one.